Okay guys, welcome to chapter 10. We're just going to start dealing with inequalities. And an inequality is something that does not equal each other. And so this is an inequality with one variable. So we're going to start with some review, and just remember how numbers can be ordered. They come in order. The objective of the lesson, to review the concept of order. Numbers come in order. And to graph inequalities in one variable. Okay, this should feel kind of like a review. We've done these things before. A number line shows order relationships among real numbers. All that means is that a number line puts numbers in order. Okay, so we can use descriptions like left or right, less than or greater than. So let's look at this. And just remember, -4 is to the left of 3. So what we say is -4 is less than 3. You use words or you can use symbols. The crocodile mouth goes to the bigger number. Okay? Or we could say 5 is to the right of -2. So 5 is greater than -2. And you can use the symbol. 5 is greater than -2. Now, we're going to introduce the idea of comparing with a variable. The value of a variable may be unknown. So when you have an x, you don't know what it is. But you might know that it's bigger than something, or equal to something, or less than something. For example, if I say x, notice the symbol, this means greater than or equal to. X is greater than or equal to 5. So I know something about x, even though I don't know everything about it. X is greater than or equal to 5 is another way of writing that x is bigger than 5, or x is equal to 5. Okay, let's look at our examples. Example 1. Translate the statement into symbols. How would we do -3 is greater than -5? You would need to go like this. -3 is greater than -5. Notice the greater than symbol. It matters which direction you go here. Example 2. X is less than or equal to 8. X is less than or equal to 8. Here's all the symbols you need. Less than, greater than, less than or equal to, greater than or equal to, and then there's equals. And this one is not equals. Okay? Now, let's complicate it a little bit. Just a little bit. To show that x is between -4 and 2, we're going to write this. -4 is less than x, and x is less than 2. That means it's between -4 and 2. -4 is less than x, and x is less than 2. Or x is greater than -4 and less than 2. We save some space by writing the two comparisons in one statement. You can write it the other way. 2 is greater than x, and x is greater than -4. Now, you can decide whether it's true or false once you know what x is. So for example, example number 2. Classify each statement as true or false. A. -4 is less than 1. 1 is less than 2. Now, is this true? Both parts have to be true for the whole thing to be true. So is -4 less than 1? Yes. Is 1 less than 2? Yes. So A is true. Okay, let's go to B. -4 is less than 8, and 8 is less than 2. Okay, is -4 less than 8? Yes. Is 8 less than 2? No. So this one is false. C. 7 is greater than or equal to 6. Is 7 bigger than or equal to 6? Yes, it is, because it is bigger than 6. It doesn't have to be both when you say or. So that one's okay. Is 6 greater than 6? No. Or equal to 6? Yes. So that one's also okay. Even though 6 is not bigger than 6, it is equal to 6 thus making this one true. Okay, next part here. The statements given in example 1 and 2 are called inequalities. An inequality is formed by placing an inequality symbol, which is greater than, less than, greater than, equal to, or less than or equal to, between numerical or variable expressions. And they are each side is called, well, a side. So this has two sides, two sides, two sides. As with equations, an inequality containing a variable is called an open sentence. It's open because part of it is a variable. You solve an inequality by finding the values from the domain of the variable for which the inequality is a true statement. So, if I have something, let's do a simple one. If I've got something like this, x is bigger than 4, I need to solve for x. So I'm looking for, what does x equal to? X is equal to something that makes this true. Well, there's going to be a lot that makes this true. So solving an inequality is just like solving an equality. We want to know what values for the variable. What can we plug in that makes it true? All the values that we find are called solutions of the inequality. All values that make the inequality true are called solutions of the inequality. And then all the solutions together make up the solution set. And remember, we'll write a solution set in braces. Okay, let's keep going. Example 3. We're almost there. Solve y plus 5 is less than or equal to 7 if the domain for y is negative 1, 0, 1, 2, 3, or 4. So these are the possibilities for y. This is the domain of the variable. So what we're going to do is we're going to plug each of these things in for y and see which of them give us the answer. Okay, so I'm going to take negative 1 plus 5. I'm going to take 0 plus 5, 1 plus 5, 2 plus 5, 3 plus 5, and 4 plus 5. Okay, now we're going to check to see which ones make it true. Is 4 less than or equal to 7? Yes. Is 5 less than or equal to 7? Yes. Is 6 less than, you guys are noticing a pattern, I hope. Yes. And 7 less than or equal to? Yes. Is 8 less than or equal to 7? No. And neither will 4 be. So, we just checked every member of the domain. We checked every single possible y that they gave us. And so the solution set is negative 1, 0, 1, and 2. We solved this inequality. There it is. The solution set is negative 1, 0, 1, and 2. Just what we've got. Okay. When you graph the numbers in the solution set of an inequality on the number line, you're drawing the graph of the inequality. So if we take the answers and put it on a graph, then we have the graph of the inequality. Okay. The graph is shown here. So actually there's just a dot at each number. You have to put all the numbers, and then you put dots on the numbers where it goes. Okay, graph number 4. Graph negative 3 is less than or equal to x, and x is less than 2 over the domain of all real numbers. Okay, so this is going to use closed circles and open circles. Now, in order for this statement to be true, we need x to be bigger than or equal to negative 3. So notice the closed dot includes the number. And x has to be less than 2. It does not include 2, it's less than 2. We don't want it to include 2. So everything between these two numbers is correct. And so we shade it in on the number line. Okay, that's it. So go ahead and start your assignment. Let me know if you have any questions.